Hello and welcome. Wanted to do a quick video for you seventh graders today about the topic of momentum. We're going to be talking about this more in class, but I wanted to just go ahead and get this up on the classroom page so that everybody had access to it. And we talked the other day about velocity, how velocity is both speed and direction. And that becomes really important with things like momentum because velocity has a directional component, so does momentum. It allows us to do some problems where direction is a factor later down the line. But today I just want to talk about the most simple kind of momentum problem, and that's using the equation for momentum to solve and discover the momentum of a moving object. So what we'll do today is quickly review the momentum formula, and we'll talk about how to solve simply for one object in momentum, and we'll do some collisions and things later on, again related to direction, but we'll just start with this. So here we go. The momentum formula is P equals m times v. A little bit confusing that P is the letter they selected to represent momentum. I suspect it's probably because they were running out of stuff to give an M to, right? There's megameters, micrometers, millimeters. There's all kinds of stuff that starts with M. So maybe they just found out that nothing was using the P and threw that in for momentum. Not really clear why, but that's what the P stands for. The M here represents mass, and you could use many different units of mass for this. It's not specific to kilograms, but as we'll see in a minute, the unit you use going in is related to the momentum unit coming out. And then finally, velocity, ordinarily in meters per second, but again, not necessarily related to that. There are different units we could use for momentum. So we'll talk about that in just a moment. So momentum equals mass times velocity. Let's take a look at our question here. This says we have a 5 kilogram bowling ball rolling west at 2 meters per second. So simply to solve a problem like this, we just take our momentum formula, P equals m times v, and we plug in all the information that we know. We know that the bowling ball has a mass of 5 kilograms, so we can say that P here is equal to 5 kg, that's the mass, times the velocity, 2 meters per second. And then really very simple, we just got to multiply across. There's one little bit of trickiness in the units, but we'll talk about that in just a second. So let's think about it this way. Let's just think about the numbers. 5 times 2 is 10. So our number that we're going to sort of get out here for momentum is 10. And the question is really, what unit do we now use? Well, if you kind of think about multiplying kilograms as a fraction by meters per second, okay, and of course we do need to include that direction as some information in there, so the direction west. What we really end up with is here kilograms over 1 times meters per second with that directional component. So our unit ends up being 10, we just multiply across, kilogram meters, kgm, per second west, okay? And here is what our final momentum of that bowling ball is. Now you can start to do some thinking about what would happen if we changed some of the numbers like velocity. So what if we had a smaller bowling ball, say 2 kilograms, but it was going faster, say 5 meters per second? Well, that object would have an equivalent momentum because 2 times 5 is still 10. So 2 times 5 gets us 10, 5 times 2 gets us 10. So a 2 kilogram bowling ball going faster, say in the opposite direction, would have the exact same momentum as this larger one going slower in the westerly direction. And that's where we're going to kind of head down the road. But for now, I think that covers you. Have a happy and momentous Halloween.